Here is an example. We compute the Fourier series of this square wave function. So this function equal to -1, say for minus pi less than t less than 0, equal to +1 if t between 0 and pi, it has 2 pi period. The smallest period is 2 pi, and the values here as 0. So at pi, at 0, minus pi, 2 pi, minus 2 pi are 0. So this is an example of 2 pi period function. F of t equal to 0 if, say, we talk about the period on minus pi and pi. This function f is 2 pi period. So outside that, it just keep repeating. So it is equal to 0 if t equal to minus pi, 0 pi. It is equal to -1 if t between minus pi and 0. It is equal to 1 if t between 0 and pi. That's our function. So here's the highlight of our function. Equal to -1 for t between minus pi and 0. Equal to 1 for t between 0 and pi. And equal to 0 at those points, minus pi, 0 pi. Other than that, you keep repeating this pattern again and again. It has 2 pi as a period. So let's compute the Fourier series of this function, the square wave function. The Fourier series ft equal to a0 over 2. This is the formula for function, piecewise function of 2 pi period. M from 1 to infinity, am cosine mt, bm sine mt. To compute a0, you integrate both sides of this equation and you do it term by terms. So integrate, I can put integrating here and here, and all of these terms and this term will give us 0, except this one is non-zero. And so we have minus pi to pi integral ft dt a0 over 2 minus pi to pi dt. This term gives us 2 pi divided by 2, so it's pi times a0. a0 equal to 1 over pi integral minus pi over pi ft dt. So that's how we get the formula for a0 for our function from minus pi to pi. So it is piecewise continuous, so I will break it into minus pi to 0 plus 0 to pi. 1 over pi minus pi to 0 ft dt plus 0 to pi ft dt. And now we plug in the values of the function f on each of these intervals. So 1 over pi on minus pi to 0 ft equal to -1 from minus pi to 0. -1 times dt on 0 to pi is equal to 1. So you have 0 to pi, 1 times dt. Now this is 1 over pi minus t. You plug in the values, the limit as minus pi 0 plus t 0 to pi. 1 over pi minus 0 minus pi. That's for the first terms here. For the second terms, it's just pi minus 0. So this one equal to 1 over pi minus pi plus pi, which is 0. So our first coefficient a0 equal to 0. Now we do am. M greater than equal to 1. Am for the one for cosine, you multiply cosine and t both sides. You do integrating. All of these terms will be 0 except when m equal to n. This one will give us pi. So to compute that, we multiply cosine nt to both sides. So, and then you integrate both sides. So I can do it from minus pi to pi. dt. Integrate these terms from minus pi to pi. So this one 0, this one 0, this one, the only non-zero term is when m equal to n. M equal to n, you have an minus pi to pi cosine square nt dt, and this one equal to pi times an. So later you can just use the formula an for any n greater than equal to 1. You get 1 over pi of the interval cosine nt ft dt minus pi to pi. So this is a formula coefficient in the Fourier series. In our case, you have 1 over pi, because this function is piecewise continuous. So I break it into minus pi to 0, cosine this terms times ft to 0 pi. Now 1 over pi minus pi to 0, ft for t between minus pi and 0 is minus 1. So minus 1 times cosine nt dt 0 to pi. On 0 to pi, this one is 1. So you have cosine nt dt for t from 0 to pi. Now you need to do computation. 1 over pi minus still there. We have sine nt, and remember to divide that by n. This one for t from minus pi to 0. For the second terms, you have sine nt, and remember to divide it by n. Now between 0 and pi, 1 over pi minus 1 over n sine 0 minus sine minus n pi. That is our first term here. for the second terms, this one, we have 1 over n psi n pi minus psi 0. So this is 1 over pi psi 0 equal to 0. Psi minus n pi minus 1 pi minus 2 pi, they are all 0. So these terms are 0, 0, 0, 0. This one term 0, which is 0. So for any n greater than 1, all of these are 0. Now we need to compute the last part, Bm. For Bm, you do similarly. You multiply psi nt both sides, you do the integral both sides. And with that, you have Bn for any n greater than equal to 1 equal to 1 over pi integral minus pi to pi f of t psi of nt dt. So you do the same thing as before. Break that into two intervals. And now I do it quickly. For ft on this interval is minus 1. On the other interval is plus 1. For the first terms, you have minus, so it is minus cosine nt, and you have 1 divided by n. So minus minus, we have positive 1 over n cosine nt. This is for this first term. For the second terms, remember that's 1 minus pi to 0. For the second terms, you have minus 1 over n cosine nt 0 to pi. So this one, 1 over pi 1 over n cosine 0 minus cosine minus n pi. So for the first term, for the second term, 1 over n cosine n pi minus cosine 0. So we have cosine 0 equal to 1, cosine minus 1 pi minus 1, minus 2 pi plus 1, minus 1 plus 1, forever like that. So you have 1 over pi 1 over n 1 minus cosine n pi. So cosine minus n pi equal to cosine n pi. In general, cosine theta equal to cosine minus theta. So I draw this unit circle here. Say we have theta and minus theta. They will give us the same cosine. This is the cosine. That's why we have this. That's for the first term. For the other one, here you get minus 1 over n cosine n pi minus 1. Cosine 0 is 1. You can group this 1 over n, 1 over n. 1 over pi times 1 over n inside of 1 minus cosine n pi minus, that is for the first part. For the second part, minus cosine n pi minus 1, so minus 1 plus 1. Then you have 1 over n pi, 2 minus 2 cosine n pi, 2 over n pi, 1 minus cosine n pi. This one will be plus 1 minus 1 plus 1 minus 1. So 2 over n pi, 1 minus 1 to the n. So for n is even. N is even. This term is 1. 1 minus 1, 0. So this is our Bn for n greater than or equal to 1. You have 0 if n is even. And if n is odd, this term is minus 1, then you have 1 minus 1, so you have plus 2. Plus 2 times 2, 4 over n pi. This is our coefficient Bn. Now you get all the coefficient. You can write down the formula, the Fourier series of the square wave function. Square wave function f is ft a0 over 2 sum m from 1 to infinity am cosine mt bm sine mt. a0 and am, they are all 0, and for bm here, this is 0 when it is even, and when m is odd, we have this. So all the terms 0, 0. So we look at the non-zero terms only when m is odd. bm sine mt. Now bm when m is odd, 4 over m pi. bm, m is odd, bm is 4 over m pi. 4 divided by m pi. And if you want to write down without using both, then m equal to 2n, m is odd, m equal to 2n minus 1. You can use any other notation, n greater than or equal to 1. So you have 1, 3, 5, and so on. N greater than 1 to infinity, 4 over 2n minus 1 times pi, that is for these terms, sine 2n minus 1 times pi t. So I can take all the terms that doesn't depend on n outside. 4 over pi, inside you have n from 1 to infinity, sine 2n minus 1 pi t divided by 2n minus 1. So this is ft. This is the Fourier series of f. We can graph the function for the first few terms of n. Here I draw the graph with the first 3 terms, and you see this is the approximation for this. It goes like this. And you see here we have the so-called Gibbs phenomenon, which is overshooting at the point of discontinuity. Just go a bit up and down, so overshooting at those points. And this behavior at the discontinuities is typical, and it is known as Gibbs phenomenon.